Hello, thank you for joining me today for a presentation on my senior project. For my project, I worked with Webcor Concrete Group to conduct data collection and analysis at their housing construction site on the Cal Poly campus. This led to the design of multiple process improvement recommendations that aim to increase fieldwork efficiency. My name is Fiona Blackburn, and I'm a fourth-year industrial engineering student at Cal Poly San Luis Obispo. I will begin my presentation today by identifying the problem that led Webcor to partner with Cal Poly on this project. I will then discuss the data collection and analysis that informed my process improvement designs. Once these designs were analyzed through focus groups with multiple stakeholders, a business case was developed for the final recommendations. I will conclude my presentation by sharing the secondary impacts this project may have and the industrial engineering tools I applied to complete it. Webcor chose to pursue this project because they have identified the potential for large economic savings if fieldwork efficiency can be improved. Currently, they feel there is a high level of inefficiency between the end of a worker's break and when they resume productive work. They are also concerned about violations of the 30-30 rule, which states that anything a worker needs should always be accessible within 30 seconds or 30 feet. Therefore, the problem statement for this project states that Webcor wishes to utilize their field hours 5% more efficiently through a study of current shortcomings and recommended improvements. The data collection procedure for this project was informed through my literature review. By researching previous studies done on construction sites, I identified 5 potential methods for collecting the necessary data. These were analyzed using the multi-criteria decision analysis shown, and activity sampling and worker surveys scored the highest and were both used for this project. Throughout the data collection process, these methods were redesigned multiple times to improve the data being recorded. The scope was also narrowed to only include the Cal Poly housing construction site and 2 foreman crews in order to make data collection feasible for 1 observer. These decisions were discussed with the project sponsor, who was supportive of narrowing the scope to produce more accurate data. On the top here, you can see the final version of the spreadsheet used during activity sampling. I was ultimately only able to observe 3 workers at a time instead of an entire crew due to the size of the site. Additionally, the times were broken down into more manageable 6-minute increments as opposed to the original 15-minute increments. On the bottom is the sheet workers used to track their own violations of the 30-30 rule once they understood the project goals. The results seen here are only taken from the activity sampling and are averages over both observed crews. As you can see, 30-30 rule violations have the largest impact between breaks 1 and 2, and the most unproductive time was actually seen at the start of the day, not after either of the 2 breaks. The following Pareto charts show which 30-30 rule violations had the greatest impact on fieldwork efficiency. They were compiled from a combination of activity sampling and worker survey data. Each block represents an occurrence of a worker needing to go farther than 30 feet or 30 seconds to retrieve the item, and the height shows how long it took. The orange line and right-hand axis can be used to identify which items account for 80% of the lost time and should therefore be focused on. In the case of the deck setting crew, these items are shoring beams, saws, bracing clamps, wood, ladders, and tie wire. This Pareto chart shows the same information but for the deck stripping crew. There were a lot of items that fell above the 80% mark, but the top few are the forklift, safety flags, and harnesses. Through spending time on the site over the past couple of months, I identified these activities as large contributors to fieldwork inefficiency. They did not all lead directly to 30-30 rule violations, but consistently came up in my field notes as areas for improvement. One to note is the Monday morning site-wide safety meetings that delay productive work for all workers. These meetings are valuable because they inform everyone of potential hazards and where other crews will be working throughout the week, but they could be run more efficiently to improve overall site efficiency. This is a preliminary list of process improvement design alternatives based on various issues identified from the data analysis. To address the high level of unproductive time between break 1 and break 2, which is the shortest section of the day, break 2 could be pushed back to 12:30 in order to smooth out the workday. The unproductive time at the start of the day was often due to retrieving or setting up safety flags and going back and forth to the job box for forgotten tools. This could be minimized by always ensuring the flags are returned to the box at the end of the day and improving the job box placement. Saws and ladders were the only two items above 80% for both crews, so another suggestion is to better manage or purchase more of these tools. The largest observed issue for the setting crew is shortened posts, which are currently stored on large, heavy carts that are challenging to move. If the post could be brought closer to the work area on more transportable carts, it would likely reduce the number of 30-30 rule violations. To address the issues the stripping crew had with using the forklift driver could be included in the scheduling meetings to help smooth demand. Finally, the previously mentioned site-wide safety meetings could be made more effective if the information was compiled ahead of time and announced by one person instead of going around to many different speakers throughout the meeting. These results were then analyzed based on their potential feasibility and effectiveness by the stakeholders seen here. Since it was not possible to actually implement these improvements during the project timeline, these results will serve as an indicator of which ideas may prove to be the most useful and should be included in the final recommendation. The survey results can be seen here. Both the worker crews and the site managers ranked the fourth option of placing the shores on smaller carts as last with a 6.9 and a 6, and they ranked the first option of starting lunch later as second to last with a 7.9 and a 7, so neither of these options will be further considered. However, the rankings for all other options varied widely between the workers and the management, so these will be analyzed in the following business case. An economic analysis was then performed to further assess the remaining 4 process improvement ideas, and they are listed in descending order of annual profit. For these calculations, it was assumed that workers cost Webcor approximately $80 per hour. The first improvement would require additional labor costs to take down the flags at the end of the day. However, the workers are generally working where the flags are, so it would not be too much additional effort to take them back to the box with them at the end of the day. This would incur greater savings in the mornings because workers would not need to go back and forth to get the flags, and the whole crew could get going faster. The second idea does not have any cost associated with it, so any time saved would be straight savings. However, the 3-minute reduction is an estimate as this would need to be implemented to see how much the meeting could truly be cut down by. Including the forklift driver in the morning meetings requires the additional cost of paying the driver for about 30 minutes daily. However, if the forklift were utilized more effectively, it could result in huge savings across the site, so my economic analysis showed that this would be a worthwhile process change. Finally, purchasing more saws and ladders is the only recommendation that requires an upfront capital investment. It was assumed that the saws and ladders would need to be replaced annually, but if this is not the case, the profit could be even greater than that shown. The business case showed that all 4 final process improvement recommendations would be profitable for Webcor. Therefore, my final recommendation is that once the assumptions made for those calculations are verified, Webcor should implement all 4 changes as a pilot program at the Cal Poly site. Additionally, if they would like to generate further process improvement ideas, the data collection and analysis methodology used for this project could be easily repeated for other crews or sites to expand upon this project. There are also some secondary impacts to consider when determining how to move forward with these potential improvements. This project could result in employees being laid off if changes are implemented successfully and Webcor requires less field work hours. In terms of organizational impact, any process improvement project requires a culture shift at all levels of the company and potentially additional training. Before implementing changes, Webcor should ensure that their company is prepared to handle this impact. The industrial engineering tools seen here were incredibly helpful in completing this project. Engineering test design was used to develop the data collection plan, which was then carried out through data collection and analysis. General process improvement principles that I've learned throughout my coursework at Cal Poly helped to inform my process improvement design ideas. Finally, multiple data collection methods and process improvement design alternatives were analyzed throughout the project, which ultimately led to the final recommendation to Webcor. Thank you for taking the time to view my presentation.